In lesson 9.1, we reminded ourselves how to use substitution, and we use that to solve the linear, nonlinear systems of equations. So today we're going to go back to just linear systems, and this time use elimination. I think elimination, it's my personal favorite. I think it's just a little bit cleaner. So we'll just remind ourselves how this works. So in order to use elimination, remember our goal is to add the two equations and for one of the variables to eliminate. So we need to have the exact same thing except opposite. So for example, in the first equation, we have 3y. In the second equation, if we have negative 3y, those will cancel. So that's going to be our goal. We're going to multiply the second equation by 3, and that'll give us 15x minus 3y equals, I think that's 51. We'll say it's 51. The top equation, I am not doing anything to. Just leave it alone. And now when I add these equations, I get 17x. The y's are eliminated, they cancel, which is good. And I have 68. So when I divide both sides by 17, I find that x equals 4. Sorry about that. We don't want to do that. Okay. So we want to write our answer as a coordinate 4, and then to get the y value, you just need to go back to one of your original equations. I'm going to go back to the first one and solve that for y. So that's going to be an 8 that I subtract from both sides, and so it looks like y equals 3. Okay, so this should be a review from Algebra 1 and Geometry and Algebra 2. We did this a lot. All right, let's try another one. We want to eliminate a variable. It does not matter which one. I'm going to eliminate the x's. If you decided to eliminate the y's, that would be totally fine. So to do that, I'm going to multiply the top equation by 2 so that I get 6x plus 4y equals 14. And then I'm going to multiply the bottom equation by negative 3. And that will give me negative 6x minus 15y equals negative 3. And now when I add these two equations, 6x and negative 6x cancel, they eliminate. And so I'm left with negative 11y equals 11. So y equals negative 1. So my solution is something negative 1. To figure out what the x value is, I'm just going to go back to one of the original equations and plug in. It does not matter which original equation we go to. And it turns out that x equals 3. Now, this says to solve the system graphically. To do that, you would graph both of these, and Desmos is a great way to do that. Just go over to Desmos, graph them both on there. They should intersect at the point 3, negative 1. I'll let you check that. We don't need to take the time to do that. Now, for this problem, we want to solve the system of linear equations. And this is kind of a disaster because we've got all of these decimals. We do not have to suffer through all those decimals. What we're going to do is we're going to multiply absolutely everything by 100, okay? Both equations. So that's going to give me 3x plus 4y equals 75, and 2x plus 6y equals 90. So you're allowed to do that. Just multiply everything by 100, get rid of the decimals, and then we'll go through and solve this. I think I'm going to eliminate x's again. So I'm going to multiply this top equation by 2. So 6x plus 8y equals 150. I'm going to multiply the bottom equation by negative 3. And then when I add these, the x's eliminate, and I get negative 10y equals negative 120. So it looks like y equals 12. Yep, I think that's right. So y is 12. Now I need to go back and plug into, normally we go back and plug into an original, but remember my originals had all those decimals. I don't want to go back to those. So I can come back to one of these. That's okay, that'll work too. So 3x plus 4 times 12 equals 75. Let's see, I'm subtracting 48 from both sides. So I think that's 27. So x equals 9. All right. In the next video, we'll talk about a little bit of vocabulary related to these systems of equations.